Hello, calculus fans! So, in a very similar way as we did in one variable calculus, we can compute second derivatives of vector functions. So r double prime is just the derivative of r prime. And we're going to make a definition that a curve that's given by a vector function r of t on an interval I is called smooth if r prime is continuous and r prime of t is never equal to the zero vector. Except we'll allow that at the endpoints of the interval. So as an example, this curve, r of t equals 1 plus t cubed, t squared, is called a semi-cubical parabola. And let's determine if this curve is smooth. Alright, so we compute a derivative. We see r prime of t is 3t squared, 2t. And notice that if we plug in 0, we get the 0 vector. And so that tells us that this is not a smooth curve. We're going to take a look at the picture in a moment. And when we do, we'll see that it has a sharp point. That's also called a cusp. That happens at t equals 0. Curves that have sharp points, that's where it has an abrupt change in direction. Those are not smooth curves. Here is the semi-cubical parabola. This curve is not terribly important. You don't need to know the name. But it is an example of a curve that has a sharp point, a cusp. Any curve that's made up of a finite number of smooth pieces is called piecewise smooth. So this semi-cubical parabola is, in fact, piecewise smooth. We'll be using that term later on in the class. Okay, that's all for now.